Hello, everyone, and welcome to this session on AI in telehealth applications. My name is Svein Willassen, and I'm the General Manager for Telehealth in Daily. And I have with me today Andrew Seagraves from Deepgram. Andrew, can you tell us a little bit about yourself?
Sure. It's nice to meet you all. I'm a VP of research at Deepgram. I've been at Deepgram for several years now. I was an early research scientist there. I've worked on a number of problems in speech recognition, and now focusing more on generative AI and large language models and things in that space. So very excited to talk to you all today.
It's great to have you. So, Andrew, I've been thinking a lot about what AI can do in telehealth, and having worked myself with telehealth for approximately 6 years, I see a lot of opportunity for making the everyday life easier, both for patients and providers, using artificial intelligence applications. So I'm really excited to go into this topic. One of the first things that springs to mind, I know, is something that you've been working a lot with already, and that is transcription, turning the spoken conversation in a consultation into something that's written. Can you tell me more about how easy it is to do that?
Great question. So I tell you, over time, within a fairly short period of time, a couple of years, it's gotten a lot easier than it used to be. Still a very hard problem in many particular domains. So just to give you an idea of like 2 or 3 years ago, when I started at Deepgram, we had a number of domains. The health domain was one of them, where our models would get like 30% error rate, something in that range, so 70% accuracy. A model at that accuracy level is not really usable. It only becomes usable when your error rates drop to like 15%, and it becomes very, very usable when they drop to 10% and below. And within 2 years, we have now hit the 90% accuracy level across a very broad number of domains. Health still remains a challenging domain. It has a lot of unique aspects which are difficult for speech recognition. So it has some of the typical challenges that you see in terms of the broad heterogeneous characteristics of the input data. That's like you have to transcribe speech for many different kinds of people, and they have lots of different speech patterns. So like the way they speak, the prosody, the accent that they have. So you have to be able, your speech recognition technology has to work well across accents. And then there's a lot of specific words that are rare, relatively speaking. So rare words, jargon, if you will, technical jargon, that is highly specific to the medical domain.
Or medical jargon, I guess. Medical jargon, for example.
Medical jargon, that's right. And so like you face a lot of the big challenges that you typically face in speech recognition. You know, the model has to work well for everyone. There's a lot of unique speech patterns out there, medical jargon. And then a third thing has to do with the fact that you have, if you're transcribing speech of an encounter of a doctor and a patient actually in a room together, and you have people speaking into a microphone. The microphone is placed somewhere in the room, and you'll have what we call far field audio problem. You may have the mic attached to the doctor, and their speech is picked up very clearly, and then the patient, their speech might be significantly deteriorated in terms of the quality in which it's picked up by the mic. And then you have the difference between the two.
Right.
in clarity level. So that's called the far field audio problem. That's another like hard problem that speech recognition systems have to solve. They've gotten better on all of these problems to the point now where the technology starts to become usable.
But does it mean that it would actually be easier to realize transcription in a telehealth setting where the patient and the provider is in two different places using separate microphones?
Yeah, so that's actually a bit of an easier problem than when you're trying to recognize speech for two people in a room. So you may not have the far field audio problem. You may be capturing those two speakers on different channels, and then you can transcribe the channels independently. That actually becomes a much easier problem. You still face the challenges associated with transcribing difficult to recognize speech patterns and rare speech patterns and rare words. Yeah. Yeah.
When you say 90% accuracy, what does that mean? Is it do you have like something that's transcribed manually that's you compare the machine output to? Is that what accuracy means?
Yep, that's exactly right. So speech recognition is a, like, I would call it a hard science, in the sense that we do labeling at very large scales. And so there's companies like Deepgram that have built up the capability to label in-house. And it's actually one of the key technical capabilities that you need to have to be able to develop very accurate speech models. So we have to be able to label our own data. We use that labeled data to train the models, and then we use it to test the accuracy of the models after the fact. And so this is one of the very interesting things about speech recognition, is that there's fairly well accepted ways of doing this error characterization. So everyone is kind of speaking the same language. Speech recognition companies can measure the errors on their own data. Our customers who are using our service typically also have their own hand labeled data, and they can measure the accuracy of Deepgram speech recognition on their own data as well. Yeah, so there's fairly well accepted ways of doing this error characterization.
That's very interesting, and the accuracy rate that we have currently is, I guess, it has been improving quite a lot over the last few years. Do you see it? Is it still improving, or will it reach like a level where it can't go any further?
Yep, that's a great question. So it is still improving. I would say that it's a bit of a nuanced picture that you have to paint. So you have different domains. You could think of, in a broad sense, you have like phone calls. That's a domain you could think of. You have meetings. You have, let's say, podcasts, videos, things like that. Then you have, say, more smaller domains like the doctor-patient in a room scenario. Yeah. So you could think of that as a domain. Like another specialized domain you could think about is someone at a fast food ordering window talking to a bot trying to order something, and you have people in the back seat of the car and the front seat of the car also talking. Yeah. This is a domain that is now using speech recognition technology at large scales. So what you see is like strong accuracy differences across these domains. Broadly speaking, models are getting really good at phone call, and accuracy is starting to approach 90%. But that's like an overall average. You still have a lot of cases where the model will produce 20 to 30% error rates. Just like on the bulk of files, the errors will be pretty low. On the more challenging applications that involve far field audio and things like that, models are still in the 20 to 30% error rate range. So there's a lot of room for improvement there. So I would say, like, generally speaking, we can continue to expect improvements, but it's going to be diminishing returns. So like the accuracy is starting to level off as it's approaching 90%. Eventually you're going to get to like 95% across all domains. You can expect that as companies like Deepgram are able to collect enough data across all domains, so given sufficient time and sufficient usage of the technology, we will eventually hit the saturation level in accuracy. And that's the point at which the model is predicting as well as a human can label the data, basically. So we'll hit human level. We're already starting to approach human level in some narrow, easy domains like podcasts, where the audio is very clear, things like that. But see, even if you look at a human transcription, it will have errors in it. So you'll be able to hear, if you're listening to the audio and reading the transcription, you'll spot errors from here to there. So the truth that you're comparing against will even have errors.
So
Eventually,
that's 100% then when you have reached the human level.
There's one level beyond that, where the model will eventually be superhuman in its ability to predict, where there's things that a human cannot. There's actually like scenarios that a human have a very hard time labeling. So one of those is crosstalk. When you have two people who end up speaking at the same time, or you could have two or more. So you could have three people who all end up speaking simultaneously. Humans have a very hard time like disambiguating those signals. But a model in principle will eventually be able to do that. There's very few examples in the literature at this time of models that are actually like predicting crosstalk well, but eventually they will. And when models can do that, they'll be superhuman in their capabilities.
So you can just place a microphone in a public place and it will pick up all the conversations that's going on then.
Yep, that's right.
In theory, at least. Very interesting. So for a telehealth setting, it's also interesting to think about what's the applications for this. And one of the very common questions I get from people in the industry is, when will we have not only automatic transcription but also automatic summarization? As you know, in a clinical setting, the provider always has to write a clinical note based on the conversation with the patient. So I assume this is an application of what we can call summarization. So making a summary using some kind of machine learning, I guess, out of transcript. And this is an active field of research, isn't it?
Yes, it definitely is very active for several years now. In the machine learning community, people have been working on summarization. The summarization research area started with models that were built specifically to summarize based on human labeled data. One of the aspects of summarization that makes it very difficult is that summaries are very challenging to write for humans. It takes a lot of time for a human to sit down and read a transcript and then capture it in a succinct summary. And so that's just one fundamental issue. It takes a long time for humans to generate summary labels. So part of the challenge in summarization, especially for particular domains where the conversations are challenging to read, is just the time and cost associated with it. So it's difficult to label for summarization at scale. So I would say that like summarization is relatively data poor domain. There's a few data sets out there that have been mined from public sources that most of the summarization models have been trained on up to this point. For example, Reddit. Reddit has a subreddit called TLDR, where you have a much longer block of text, and then you have someone writing a summary of that. And TLDR produced, I think probably the largest summarization data set so far. And
so you would need to train a model to do proper summarization. You would basically need a lot of data summarizing transcripts in a specific way, I guess.
Exactly. So that the data that's available publicly is not really tailored to any particular domain. You could train a model to do general summarization on text data, but these models would not then work well for conversational data. Conversational data is you could say it's out of distribution compared to the kind of text data that you would have on the internet. And so for several years, summarization models were being developed, but they didn't work well for conversational data. And then you probably had specialized players who were working on NLP applications, who were labeling their own data, labeling their own conversational data, and then taking a model that had been trained on data available on the internet and adapting it to a smaller amount of data. And that approach gets you, so far. You can have a summarization model that works okay, but it probably has lots of failure cases. It's probably difficult to adapt it to new use cases that pop up, because then you have to generate, hand labeled data for those use cases. So now we have the outlook is changing for summarization recently, because we have a new technology that's hit the scene. LLMs,
large language models.
Large language models, I think are really changing the game. In many ways. So
I was going to ask if you're looking having the need for training data. If you're a health record solution, for example, presumably there's a lot of clinical notes in your system already. So if you then would be able to populate it with transcripts from the same consultations as well, maybe that could be used as training data to create automated clinical notes.
Yep, that's right. So you have a lot of training data at your disposal in this application. One approach that you can take to summarizing that data is to use a large language model. One of the amazing capabilities of these models is that you can engineer them with a prompt, and so you can basically program into the model via natural language what you want it to do. You can ask it to, you can tell it, I'm going to present to you a transcription of an interaction between a doctor and a patient, and also I'm going to provide some elements from an electronic health record. Please summarize to me the key aspects of this that you would then populate into the record, something to that effect. And the model actually, depending on the quality of the LLM, may or not be able to do that task in many cases.
I have actually tried using ChatGPT, which is a large language model, to do this already. Not for medical summaries, but for other, paste a bunch of text and ask it to make a quick summary of this text. And that seems to work amazingly well.
Yes, it is kind of incredible, and it bears emphasis. These large language models were not trained specifically to summarize. They were trained by and large, if we're talking about a GPT style model, that'd be the basis for ChatGPT. They were just trained to predict the next word given some block of input text. So to predict the most likely next word. And from this simple task of next word prediction, and then also that coupled with training them effectively on the entire internet, all available human text, filtered for quality to some extent, you then get this model that has formed some representation, like a complex, nuanced representation of language and of the world. So it knows things, and then it can also understand humans. So they can ask it to do things. Out of the box, these models, after their initial pre-training to do next word prediction, they don't really do what humans want, generally speaking. We call this alignment. They're not well aligned with humans. They have all this innate capability within them, but you just have to point them in the right direction. And so, companies have been working on this companies and research groups have been working on this for a couple of years now, and have figured out how to align them with what. And ChatGPT was an example of that.
So in theory, it should already be possible to make good summaries of transcripts using something like ChatGPT or a similar large language model. Do you think that will be the way forward for summarization? Is that what everyone's going to do next year or even this year?
I think a lot of people, in the very near term, people will start using these large language models to do these kinds of tasks. So they are really like the tool that's available right now. And they work pretty well some of the time. So because they are now more broadly available, they work okay. Anyone can sign up and use ChatGPT. This will be the approach in the near term. However, there's a number of limitations of using these large language models. One is that they're general. They've been trained on the internet. They're not tailored to a specific use case. And then also conversational data may be difficult for these models to process. So they may get confused by a conversation and give you outputs that you don't expect. Another problem that these models have is that...
Do you think it would mix, like for example, if we have in a consultation, we would have a transcript where we have the patient says something, the provider says something, and it goes on like that for a whole consultation. Do you think it would mix the inputs from the different actors? It's kind of unable to discern the different actors in a conversation.
Yep, exactly. That's one thing that can happen. So when if you read a transcript of a conversation between two people, it's often difficult for humans to disambiguate. So like a large language model has to be able to discern the roles of the speakers. It has to do implicitly like role identification, and then it has to track that throughout the history of the conversation. So it is possible for a large language model to incorrectly attribute a block of the transcript to the wrong person involved. That's one thing. They can also hallucinate. They can make up facts. And that is like hallucinations become more prominent when a large language model is processing text that's well outside of its training distribution. So you can have hallucinations for conversational data. That's also true. And
I would say for a telehealth application, you definitely don't want facts to be made up by a machine.
Yes, this seems like a highly undesirable trait of these models. So one, it's difficult to keep them from doing this. It's difficult to guarantee that they won't do this. Like you'd like to have certain guarantees on the system. So those are a couple of things, and then another big limitation is the size of these models and the speed at which they run. And so generally speaking, like the early chatbot models that have been deployed commercially were derived from very, very large language models, hundreds of billions of parameters. We've deployed and tested quite a bit models of this size at Deepgram internally. And what you learn very quickly when you're dealing with 100 billion parameter model is that you need lots of machines to stand up a single model. And then inference is inherently going to be slow.
So it's an expensive thing to run. Like you need a lot of hardware to run it, basically.
Yep, you need a lot of hardware. And then even if you have enough hardware, just to be able to do inference with this model, it's still going to be slow. And so they're fundamentally limited and difficult to deploy at scale. If you have a lot of audio or a lot of text that you want to process, an LLM is not a great solution for that, to do very large scale processing or for real-time processing. That's another area of limitation. So I think
it takes time to digest the data more or less and produce output, and probably longer time than it's not fast enough to do it real time.
Yes, that's right. So I would say that that's one of the biggest limitations of LLMs is that they wouldn't easily support a real-time use case for sure.
But let's say that So I think at least for an application where we're aiming at making automated clinical notes, the processing time maybe isn't that. You don't need a clinical note to be finished straight away. Indeed, many doctors write all their clinical notes at the end of the day after having all the consultations. So it doesn't have to be ready straight away, but it does have to be factually correct.
Yep, that's
so
right.
do you see like a way out of that problem, or do we have to live with these hallucinations?
No, I don't think we have to live with them. I think that people will quickly get fed up with them, and they'll demand something better.
Yeah.
And a solution to that problem will come in what we call domain-specific language models. So domain-adapted, built for particular purpose language models. You would imagine that like the task of summarizing clinical notes or a transcript for a doctor-patient interaction, it's like a very narrow task compared to the broad range of tasks that large language models can do out of the box.
Yeah.
And so there's this like focusing that you want the model to do. You want it to only be able to do this task. So like acknowledging that it's a more narrow task, you imagine that a much smaller model trained specifically to do a task of summarization would be a better approach. And still leveraging large language models. So you could take a large language model as a starting point and then distill it into a much smaller model that's trained just specifically to do the task of summarization on this domain-specific data. And in doing that, in that process, by specializing it, you will reduce like the likelihood of hallucinations, and you'll drastically improve the performance of the model and tailor it to the particular task that you want it to do. So I think this is really the way that people will use these large language models.
Yeah, it sounds like it's a clear opportunity for companies in the health tech space to be the actors that do this. I mean, the large tech companies who have developed the LLMs probably won't go into a million different applications of it themselves.
I totally agree. We were recently at OpenAI, and we met some of the team there, and they basically said this. So they confirmed that their major interest is in AGI. There's a lot of companies out there, and solving AGI on a long time scale. And so like they view these large language models as like an entry point into that problem.
Yeah, and AGI for the audience is artificial general intelligence, right?
Yep, that's right. And so
more like recreating the human mind in a way.
Exactly. And you kind of get the sense that ChatGPT is definitely heading in that direction at the level at which it seems to understand humans using natural language. But like, these general models they're going to remain general, most likely. And they're going to still continue to be best utilized in a chat-based format where a human is directly interacting with it with a text-based UI. Something that you'll see with these general models and big players is that they'll begin to support different kinds of input modalities. So you'll be able to provide images as input to these models. When they begin to be able to process images, they'll be able to process video, probably as input, sequence of images. And then also you can imagine, in the next year or two, they might also start to support directly speech as input. So they'll be able to support different modalities, but they're most likely going to remain general. And so there's going to be tremendous opportunity in the short and medium term for companies to develop specialized solutions in their particular industry.
Yeah, and I can imagine in the field of healthcare, there's a lot of different opportunities. It's a very broad field that has a lot of specialities in it. So, just thinking about the possibilities of having AI being able to reason on an inputted image, for example, has a lot of potential applications in healthcare. Everything from MRI images to just photos of a skin rash, for example. It could be interesting to do something like that with.
Totally agree. Yep.